So welcome to OFCM session 9 of G4 of this year 2022. Also, I welcome people who are watching live and deferred live on YouTube. As usual, we go back with what we have done in the last class. Before that, I should keep my participant list to my right. Okay. Okay. So let's do with where we have left out. Okay. So it's a review question. That day we had sets A1 to AN. Okay. So these are subsets of X. So how do I write that? I have to write like this. For each I in 1 to N, here itself I have to write. Okay, this is our way of writing. For each I in 1 to N, AI are subsets of X. Okay. Oh, usual way will be like this. AIs are subsets of X for 1 less. I can write like this also. For 1 less than or equal to I less than or equal to N, AIs are subsets of X. X is some set. Okay. We defined union and intersection. Quick recall. So, union I equal to 1 to N, AI. What is it? So now direct. How many of you are ready? Quick. Any one of them is okay. This is also a way of writing. Okay. This is our way. Both means same. Right. So just to remind you, each level mentors are very active. They are picking you who is responding, who is not responding. And we are taking very strict action also. Those who are not responding for 3 or 4 times are going to be suspended. Participate. If you don't know, fantastic. See here, and if you make mistakes also, doesn't matter. We say, try, okay, participate. That's the first level. Then discuss. You need not know whether it's a mistake. Commit it again and again, doesn't matter. We will see what happens. Okay. Let's go to R3 today.
Abhinaya.
It's revision, Abhinaya. Quick. Quick.
Set of X belongs to capital X such that I belongs to set of 1, 2, etc. to N.
With what property?
Union.
Yeah, because maybe network problem. Initially we are hearing slow, then we heard fast. Okay, network issue. You say the property. With what property? Vinaya?
X belongs to AI.
Very good. X belongs to A. Good. Okay. Now let's look at intersection. Okay. So let's ask from same people, set of people. I'll clear all the feedback. Again, respond quickly. Good. This is what is wanted. Right, 20 seconds. Within 20 seconds, I should see completed. Yeah, let's go to someone from R9.
Akhilandeshwari.
X belongs to X such that for all I belongs to 1 to N.
Correct.
X belongs to AI.
Fantastic. Good. Okay. That's fine. Right. Okay. See, among these two collections, okay, we have different new sets, right? Union, intersection. Now my question is there a comparison between these two? Namely, union and intersection. Call this as set B, call this as set C. Okay. B is this, C is this. Okay. Is there a comparison between A and B and C? Quick. I'm clearing all the feedback. Obvious relation, all of you know that. Okay. I'm not asking for the proof. I'm asking why. Let's think also that. Okay. If some of you are through with that, you can actually think why it is so. Okay. Somebody from R5. R5, Kavipriya.
Yes, sir.
Kavipriya.
Sir, C is a subset of B.
Very good. So we'll now rub the notation just for a second. So intersection is a subset of union, right? Okay. Now let's try to prove this. Okay. Now I'm clearing the feedback. All of you be ready. Again, 20 seconds time. Go through the proof in your mind. You want to prove this. See, already you have, in the last class, you have done a very big exercise. Okay. Proving all unions in the, for two sets you have done. Right? Lot of equivalence you have proved. Okay. Very good. I think we should start. I'll give you another 10 seconds. Let me see how many of you are ready. Good. So I'm going to ask someone from R1.
Jayashree.
Jayashree.
Everyone.
Jayashree, start.
Let X belongs to intersection I is equal to 1 to n AI.
Which means what? Good.
For all I belongs to 1 to n, X belongs to AI.
Fantastic.
Then
Right.
we can say that there exists some element. There exists I belongs to 1 to n, X belongs to AI.
Therefore, it is in the
Therefore,
union. Right.
Union.
But you have to be very precise. See, first step, fantastic. Let X belong to intersection. Therefore, the definition says for all I in 1 to n, X belongs to AI. Okay. But I should know, at least for some I, it is there. Okay. Can you say in particular it is there in some set? Then I'm sure that X belongs to union. See, if I want to say X belongs to union, I have to find at least one I from 1 to n. Okay. So do I know such an I? Of course, every I is there. So, but still, it's something like, see, you should understand the logic. It's something like I'm going to a big chocolate shop and asking, give me a chocolate. Then that fellow will laugh at me, right? Well, see, the entire shop is full of chocolates. Why don't you take one? That's what he'll say. So he'll ask me to pick actually, right? So pick and give. It's something like, there are a lot of things which are available here. Pick one particular one and give. That's the idea. Yeah. So Jayashree, can you say again the proof completely?
Yes, sir. Let X belongs to intersection I is equal to 1 to N AI. For all I belongs to 1 to N, X belongs to AI.
Fine. Therefore,
Then
X
there
belongs
exists.
to. No. Here is the place I want. Then only I will
Therefore,
say
X.
good.
Yes, there exists. Sorry, X belongs to AI.
Which AI? That's what I want to know.
For all I belongs to 1 to N.
Okay. I don't know what is N, right? Correct. N could be 1, N could be 2, N could be N is a natural number, right? So, can you give at least, see, you are telling X belongs to A1 and X belongs to A X belongs to AN. Can you give one particular set where it is? Okay. I'll say what I'm trying to say, right? For all I in 1 to N, I know X belongs to A, right? Then immediately you are telling there exists I, right? Therefore, there exists. How do I know that? I have to really find an I in 1 to N such that X belongs to A. But what does this statement says? This statement says you pick any fellow, X is there in that fellow. Here it asks, give me at least one fellow. That's what I'm telling. It's like chocolate shop. This is also chocolate. Everything is chocolate. So pick one and give to the shopkeeper. No, he'll be happy, right? Do you understand, Jayashree?
Yes, sir.
There is a gap here. So I have to say in particular, okay, I can pick one. You say which one? First one, last one, I know. Correct? Yes or no? So in
Yes, sir.
particular, X belongs to, what should I write here? Do you understand? No, still gap is there, right? I'll say X belongs to A1. Okay. Therefore, there exists I in 1 to N. Which I? I'll choose I. See, choose I equal to 1. Okay. This is the gap. Therefore, there exists I in 1 to N such that X in A. Do you understand? I'm now choosing
Yes,
a
sir.
particular quantity and telling. That's what I want. Okay. Because there are a lot of choices. Okay. If you have understood what I am trying to say, can all of you say one more thing? X belongs to some other thing. Okay. I'm clearing all the feedback. Instead of telling X belongs to A1, what else I can say? Quick. Again, I want to say, in particular, X belongs to, I don't want to say A1, but something else I can say. Still, I don't know what N is. Okay. Right. Let me see whether you have understood. Okay, let's go to R4.
Trinity.
Correct. X belongs to AN.
Very good. Fantastic. These two are known for me. Very good. Right? X belongs, in particular, I can even write X belongs to AN. Then what is my choice of I? Choose, therefore, choose I equal to what? In this
N,
case,
sir.
N. There exists I in 1 to N. I is N. And it is inside this set 1 to N. And X belongs to AI is there. Therefore, I'm through. Therefore, intersection is contained in union. Okay, I'm clearing all the feedback. How many of you have understood? I think one of you is asking doubt. Who is that? Kaushik?
Sir, can we take a two?
I don't know, because it could be N could be 1 also, right?
Yes, sir.
Yeah. If N greater than 1 is assured for me, then you can take 2. Do you understand, Kaushik?
Yes, sir.
Yeah. I'm clearing all the feedback. How many of you have understood the proof? Very good. Fine. So now let's go to, see, so far we have given finite union. Okay. Now let's do infinite union. Suppose for all n in n, an is a subset of x. Now what do I want to define? I want to define union. Okay. Textbook way of writing is summation n equal to 1 to infinity. But we will not use this notation here. Okay. We will use this notation. Union n in n, an. I want to define. Okay. See, as usual, before defining, this is a new set for us. Before defining, we want to see, okay, what is the condition of an element being there in the set? X belongs to union means what? Yeah, quick. I'm clearing all your responses. Be ready. Please understand. Now what's given? X is in A1, X is in A2, X is in A3. Now I have sequence of sets. Okay. Is there in each of given n, X belongs to A. An is a subset of X. That's what I know. For each n, there is a subset of X. Okay. Now we are going to define the union. Before defining the union, I want to look at when to an element. If X belongs to union of An, what is the condition on X? Quick. Only 25. Okay. Somebody from R8. Haripriya.
For all,
Ah,
I
for all.
n belongs to
Ah,
I 1 to n.
1 to n only. Small n. N belongs to 1 to n.
1 to infinity, sir.
But I can't write 1 to infinity. Infinity is not a real number. What is the underlying set? You are not thinking at all. It's a problem, right? Okay, from R8, somebody else? Devashri?
Yes, sir. Set of all x belongs to a capital X such
No.
that there
First, give me the condition. I don't want this set. I want condition. Please listen to my question carefully. First, we'll complete it. Then we'll write this set.
There exists n belongs to capital N.
Very good. Natural numbers. Say natural numbers, right? N belong to natural numbers, right? With what property?
X belongs to an.
Don't forget to write that property, okay? Don't
Yes,
stop with this. Most of you are stopping with this. Now you are fantastic. Tell me, how should I write this set? Yeah.
Set of all x belongs to capital X
Right.
such that there exists n belongs to natural numbers.
Right.
X belongs to an.
Very good. Excellent. Okay. I'm clearing the feedback. I could see one student is saying no, but anyway, let me clear the feedback and give 20 seconds time. Still, if you have doubt, good, ask. All of you, if you have understood, say yes, otherwise say no. Very good. Fine. Fantastic. Okay. From this, I'll ask a new question about this to someone. Okay. Let's go to R3 now. R3. R3, Jasmine. Jasmine, Jennifer. What is intersection of NN and AN? Yes. Okay. Jasmine, you are not there. Okay, let's go to Epsiba.
Sir, an is equal to set of x belongs to x for
Hmm.
all
Hmm.
n belongs to n,
Hmm.
x is equal to x is belongs to an.
Very good. So the condition is for X should be in each of the sets. Okay. Very good. Yeah. Let's stretch this little bit wide. Okay. All of you understand, no? That's the natural numbers. But I could index with anything I like. Okay. So I'll just keep I non-empty and I is called index set. It could be anything called index set. Okay. Just out of curiosity, quickly I want to bring, let's look at examples. Do not worry. Okay. Just I want to ask you, what is union of I in I, AI? I'm clearing the feedback. I think all of you can say now. You should have understood the pattern by now and you can say quickly. Very good. Yeah. R7 Harini.
Sir.
Hmm.
AI equal to
I have written already. Colon equal to. That's our definition. Yeah.
X belongs to capital X such that there exists I belongs to capital I.
Fantastic.
X belongs to AI.
But with the property X belongs to AI.
With
Fantastic. Okay, whether all of you have understood? I'm clearing all the feedback. If you have understood, say yes. I could be any index set. Of course, it's given for each I in I, AI is a subset of X. That's given. Okay. Then only I can write. See, AIs are prescribed to be subsets of already. It's given. Okay. Now we are defining union. Right? Okay. Okay. Very good. I want one of you to say intersection of I in I, AI from this group itself. Let's look at somebody from R4 itself. R4, Agatya Lakshmi.
Yes, sir. Set of X belongs to capital X. For all I belongs to capital I, subset of X belongs to AI.
But let's now understand the meaning slowly, right? Okay. Let's do the same exercise now. Okay. Then we'll look at all examples. Now I is non-empty, right? Already we know intersection is, see, given I is non-empty, we want to now again verify whether intersection of I AI is a subset of union of I in I AI. Okay. So intersection should be smaller set, union should be a bigger set. That's our intuition, right? And the index set, I could be anything arbitrary. Okay. Right. I will give you examples for arbitrary. Do not worry. We'll do that. So let's finish this and go for a lot of examples. Okay. Who are ready? Quick. I am clearing the feedback. 20 seconds. Or even 30 seconds I can give because there is a subtle argument. You have to follow that. Okay. but very less. I don't know why. You are having some fear. Do not worry. You try, no, do not worry. Don't be what people call too purist. You try. Okay. We know how to prove A subset of B. So far we have seen a lot of proofs. Try. Then go by ask questions, no? So if I want to prove B subset of C, what should I do? How should I start the proof? Right. Now I'll take an element X in B. Then what? What is the definition of B? Next question. Okay, I have. Then what is that I want to prove? I want to prove X in C. So therefore, when X is in C, okay, that's the thing you have to go. Do it, no? Right. Shalini, R9 Shalini. Start.
Let X belongs to intersection of I belongs to I, AI.
Right.
That means for all I belongs to capital I, X belongs to AI.
Very good.
How to take a particular element of that alone, I don't know.
Think about that. See, Shalini is posing a question. Okay, I'm not going to write. I hope all of you followed. Okay, start with an element X here. Okay, then what does it mean to say? Then by definition, X is in this, but I have to find one I. There it was easier for us because I could choose, I know at least, okay. But actually you can see what is the index set here. Index set, can you say what is I here in this case? I know, I hope all of you will
1
be able
to
to say
N.
1 to N. Very good. Okay. If I is 1 to N, yes, I know 2 elements at least here. Okay. That's what Shalini is asking. There it was very clear, sir, but here it was not clear. That's where I said it's a subtle point. But now look at what is the hypothesis given to you. Okay. Now I'm clearing the feedback. Who are ready with the next step? Should. In fact, I'll write what Shalini said. Therefore, for all I in I, X belongs to A. That step is said already. Now, what is the next step? Oh, only. Yeah, let me ask Kaushik. R7 Kaushik.
Sir, choose I is equal to 1.
How can I choose? I could be anything. I could be indexed. It could be set of all states, set of all cities. I could be set of all railway stations, set of all butterflies. Could be anything. I don't know what I is. I is a set, that's all. Kaushik, have you understood your mistake?
Yes, sir.
Not necessarily numbers. It could be any arbitrary thing. Okay. I thought I can finish it now. I know it's abstract, but if I give examples, you'll come to know. Okay. Abhinaya, but still I hope you can say.
Since I is a non-empty set, there exists Y in I.
Very good. Since I is non-empty, I can pick one element here. There exists I not in I. Correct? Therefore, choose I equal to that I not, right? Yes or no? Just the way in which we have written the thing, choose I equal to I not. Then what I can say? Therefore, there exists I in I such that X belongs to AI. Therefore, X is in the union. Fantastic, Vinay. Excellent.
So there exists I not belongs to capital I, no, sir.
That's right, but I have chosen I. See here and all how we are writing. Here you chose I equal to 1, right? Yes or no? I equal to I not. I not belongs to I, therefore I belongs to I, right?
Yes, sir.
Okay. Right? Or you can simply, without saying this also, it's fine. There exists I not in I, such that X belongs to AI not. Therefore, X is in union of I in I. That's also fine. Okay. Please go through the proof. I'm giving you 30 full seconds. If you are through, say yes. But don't be in a hurry. Go through the proof. I am putting everything so that you can see the proof also. Very good. That's fine. Take it to the discussion hour. If you have doubt now, if some of you don't understand, you can ask. Okay. We have started with the same proof we have given. But here I is some arbitrary thing. I don't know what it is. But what is the hypothesis given? I non-empty is given to me. So pick one element, that's all. That element is in I. Therefore, it satisfies there is at least one fellow, namely I naught in I, such that X is in A. Therefore, it satisfies the definition of this union set. Okay, X is satisfied. See here the definition. There is at least one fellow. Therefore, it belongs to you. Okay, right. Very good. Now let's see example. In fact, let's see an example for the last case. Yeah, and do examples for other cases also. Which we have done already. Okay, by now you should know, right? That day what we had in every state. Okay, there is a city, right? So what is the set we had? So S is set of states of India. States in India. Okay. What is to each S in S? We had CS. What is CS? Set of all cities in state S. In state small s. So all of you able to see now what is my index? Can you now I will clear the feedback. Can all of you capture what is the index set now? What is I here? Quick. Very good. Good. Rahul, what is happening to you? Avipriya. Safia. Okay. Somebody from R8. Krishnamurthy. Krishnamurthy.
Yes, sir.
Quickly respond. What is I here?
Sir. Set of all cities in the states.
Oh, is that right? How many of you think it's right? Quick. I'm clearing the feedback. Set of all cities. That's what he replied. See, at least respond for this, no? Quick. What is the index set? Look at my question. Index set means what? The one which comes with subscript. Okay. Very good. So Saranya, all right, Saranya, can you tell what is the index set?
Set of states in India, sir.
Yes, very good. Yes, correct. This is what we have defined. Set of states in India. Okay, let's make a new thing. Okay, let's take our index set I to be set of G4 participants. U, right? G4 participants. Of course, I'm not writing fully. G4 participants of OFCM 2022. Yesterday, I made a mistake. I wrote 2020 in my sheet. Okay. The participants of OFCM 2022. Okay. Like. So, can all of you think, suppose given a participant X, okay. Okay. Given a participant, or let's say P. Okay. Given P, a participant P in I want to define a set AP. Okay. Can you suggest something? I'm clearing all your feedback. For each participant, I want to collect something, right? That's my set. So you can look at very new ways, right? You can create a lot of sets. Yeah, R7 Kalishwari, quick.
Sir, maybe being max students.
You want to say, no. For each participant, see, if it is Kalishwari, I want to write what is A Kalishwari, right? I want to collect as a set. So you say what it is. It's up to you. You can define anything. What you said, collection of max student, I don't understand what it is. See, something very particular about Kalishwari. Okay. I'll simply say set of subjects. Set of subjects. Okay, I should not write then set. AP is set of subjects in which I'll give an example. Okay, P has scored distinction, right? Scored a distinction. Has got distinction. What scored has got distinction. Distinction is something like greater than 75%, or even I can simply say has got marks greater than or equal to 75, right? Then I'll have subjects, right? Set of subjects in, let's say, in BSc or, yeah, BSc first year, something very particular. We searched in your application, we couldn't find actually. Some of you gave, some of you didn't give. That's a different issue, right? Set of subjects in BSc first year, which you have got greater than or equal to 75. Okay, you would have done language also, right? English, okay, Malayalam or Tamil. Okay, you would have done math, say calculus or integration, whatever. If you have got more than 75, those subjects will come. If you have scored less than 75, 74 something, it won't come. Do you understand this set? AP? To each participant. If I choose Rahul, A Rahul is set of subjects in BSc first year in which he has got greater than or equal to 75%. Okay. Have you understood this set? So it could be different for each person, right? So A Kalishwari. Okay, let's write like this. A Kalishwari. Could be something like calculus. Okay, we will assume she has got in calculus and in algebra, she has got more than just only that. Okay, now I can take A Rahul. Do you understand? It could be a lot of subjects. Okay, calculus, algebra, okay, language 1. So many subjects you would have. Yes or no? For some other student, could be same also. For some of them, it could be even empty set also, right? All the subjects I have not got more than 75, only less. Do you understand the set? I'm clearing the feedback quick. Yeah. So here, what is the index set? Let's ask Lekashri of R5.
So set of G4 participants, sir.
Excellent, excellent, very good. Okay. Now try to create, no, in discussion room, try to create a lot of sets like this. Okay. Arbitrary sets. Let's do some examples, right? Okay. For me, let's start from something. Okay. Okay. Now my index set is natural numbers. Index set is what? Natural numbers. Okay, let's not worry about that first. Let's work with some simple thing. Okay, my index set is just 2. That means, okay. Now can you write R as union of 2 sets? Union I in I, AI. But let's think, what does this mean? This means I have to write R as A1 union A2. Is there a condition on any A1 and A2? I will say now. A1 and A2 are intervals. Okay, all of us know what interval is. Okay, just only this condition. They are intervals. Can you do quick? I'm clearing all the feedback. How should I take? What does this want to say? Just go by idea. Draw the real line. Okay, I'm sorry. Now let's mark geometry. Then, yeah, draw the real line. Okay, I want to partition this real line. Okay, here also it goes. Real line is not ending. Okay. So partition this real line. Partition not in the strict sense. I have not asked for any disjoint and all. So partition it into 2 sets. That's all. So you should be able to say quickly. Anyway, you can do. But you should not miss any member of R. There should not be any member of R not in this union. Okay. R equal to A1 union A2. I'm clearing the feedback. If you have a problem in understanding the question, you can ask, put a cross mark or question mark, ask me. See, when new questions are asked, people are not responding. Okay, that quickly. Why? It requires time to think. That's very good. But things are very simple here. Don't hesitate. I could see a sort of hesitation from you. Just try your luck for the day. Okay, think. Participate. I want participation. Those who are saying no, whether you are unable to do or you have doubt. Sultana? Angelin?
I have a doubt. Can you repeat again the question?
I have written all those things, no? My index set is 1, 2. Write R as A1 union A2. Tell me what is A1, what is A2. Is your doubt cleared?
Yes, sir.
So what is that you have to find? You have to find sets A1, A2 such that R equal to A1 union A2. Now my index set is finite. It consists only 2 elements. I want to write set of real numbers as union of I in I, AI. Still somebody is having doubt, or who is that? First put cross. Srinidhi? Srinidhi, you have doubt?
Sir, will you explain it again, sir?
I want to write R as union of 2 sets A1 and A2. Right? Already I have written here. A1 and A2 are intervals. Can you do it? What is A1? What is A2? The entire real line is there, no? I want to write it as union of 2 sets. Try, no? You know what union is. Try your luck. Think. Yeah. Let's ask somebody who has not asked from R to. None of you are ready now to, right? Doesn't matter. You ask Anushya. Still no? Okay, let me ask Hepzibah, quick. R3 Hepzibah. See, one example, that first example, if it comes, you'll be doing it. Hepzibah.
Yes, sir.
Yeah, you say, do not worry. Say, what is A1?
So A1, can it be equal to?
It's like asking, no, put a partition. I have this wealth. I want to share it with two of my sisters or two of my brothers. What do? I have to put up somewhere. I'll put a partition, right? And then share. That's all.
Close interval 1, 1.5.
Close interval. See, entire real line I want. Okay, you are thinking still. Yeah, somebody wants to say?
Yeah, Srinivas and Kumaresan.
Yeah. Yes, sir. Yes, sir.
I think when you think of interval, they are thinking of finite interval. So ask them whether they can think of an infinite interval to start with.
Yeah. Fine, sir. Okay. Okay. As sir asked, I'm clearing the feedback. Can you think of an infinite interval? So now that's not the question. Can you give an example of infinite interval? Quick. Yeah. Sanesha, R3, quick. Yes, Sanesha. Oh, she's cut, is it? Okay, let me ask Abhinaya.
Open interval minus infinity to 0.
Very good. Open interval minus infinity to 0. Okay. So what is the picture? Can all of you see this? Right? This we have already tried. All real numbers less than 0. All of you know this. Right? Okay. Now the question is, can you see, this is an example of an interval, right? Okay. Now I want to write. See, if I write only this, then what will happen? Okay. R is not equal to this, right? I want all real numbers. Positive real numbers are not there with me. Right? So I want one more set, right? If I choose A1 is this, can all of you think of what A2 should be? I'm clearing all your feedback quick. Very good. Yeah, Matish. All right, Matish.
It's a closed interval of 0, infinity.
Excellent. Very good. That's all. Look at how he said, he didn't say open interval 0, infinity. Okay. What will happen if I say open interval 0, infinity? I will miss 0. R is not equal to that. Now it is perfect. R equal to minus infinity, 0, union closed 0, infinity. Okay. Right. I'm clearing all your feedback. Can I try one more example? Same thing. R union of A1, A2. A1 and A2s are intervals of infinite length. Okay. Kalishwari.
So A1 be open interval of minus infinity to 1. A2 be closed interval of 1, infinity.
Very good. Fantastic. Okay. Same idea, right? I can partition anywhere here. She is partitioning at 1. Okay. Minus infinity to 1. I can even write first one as closed, right? That is also allowed. Closed, union, one command. Fantastic. Okay. Now same question. Now I'll write R equal to J1 union J2. This is your second question. J1 and J2 are open intervals. Can you do that? I'm clearing all your feedback. Again, I want R as J1 union J2. J1 and J2 are open intervals. So this example is not allowed because here I'm using closed zero command. Yeah, I'm waiting for your response. I'll give you 10 more seconds. Yeah, Tangabandi, R1 Tangabandi.
J1B minus infinity to 1.
Very good.
J2B 0 infinity.
Very good. 0 comma infinity. That's all. I have not said disjoint. Okay, the first example was disjoint union. Now let's do like this, right? 1. And here I am starting from 0 to 8. That's all. This is my first partition. Okay. First division. I should not say partition. Partition usually means disjoint. Okay. The second one is this. Okay. Something like this. Just to know pictures I'm doing. Actually, I should write here. Okay. Anyway. I hope all of you have understood, right? Very good. Good. So, now I want to write R as, okay, union of, again, let's say, union of, I'm writing, union N in N, Jn. Jn's are open intervals of finite length. I'm clearing all your feedback. It requires bit thought. I have to do systematically. I have to do, but it's not difficult. You can try. Now, what is my index set? My index set I is n, and each one open intervals of finite length. Okay. What is the intervals of finite length? It should be of the form open interval a comma b. Okay, 1, 2, 3, 4 or something like. Length should be fine. I should not have minus infinity comma 1 or 1 comma. Yes. Okay. The geometric, I get a geometric intuition, no? How should I think about this? Again, draw a real line. Okay. It's something like our, okay, what our past emperors did, right? Expand your kingdom. First, you want J1. For J1, what I can give? Can some of you suggest? So 0 is there, but I want 1. And I will expand my kingdom systematically. Okay, let's ask from someone who are ready. Okay, Abhinaya.
Open interval 1, 3.
Okay. Then I have to look at all. See, that union should be R. I don't know how you are doing. Okay. You have to say J2 also, right?
J2 is equal to 2 open interval 2 comma.
Okay.
2, 4.
Okay, I know what you are trying to do, but that will be little trouble. I have to come this way also. See, indexed by natural numbers, right? So if you start with 1 comma, then I have to go to the left also, right? So why don't you include negative numbers also in your thing quickly so that it will be easy. Rahul, yes, Rahul.
Sir, open interval 0 comma.
Okay, let's do like this. I will give because there are plenty of ways of doing it. It's not unique. So I'll give like this. I will start with minus 1 comma 1. Okay, I'll be like this. Okay, fine. Can you think of what J2 should be? I want to expand the kingdom.
J2 can be open interval.
Zero. Rahul, let's wait. Let's wait for others. We'll give 30 seconds. Okay. You also think with them. See, -1, 1. I want to have this also and then expand. So how should I think of? Just think of J2. Then think of what should be J3. Okay, J4, something like that. Okay, quick. Who is ready now? Lot of 20 people, but still I thought some of you could still proceed. Yeah, R1 Jayashree.
J2B open interval -2, 2.
Very good. What is J3?
Open interval -3 to 3.
Very good. So J2 is this. Therefore, general Jn will write. What should be Jn?
Open interval -n to n.
Very good. See, the intuition is like this. -2, 2. I am go on expanding, right? And if I go on expand, I say entire line I have captured. Okay. Right. Therefore, I'm saying R is union of n in n, Jn. Okay. Right. Of course, I have to verify. See, in the verification, what happens? Which way is easier? If I'm clearing all the feedback. First, have you understood? Still proof is remaining. We'll do it now. Have you understood the idea? Quickly respond. Very good. Very good. Okay. Even though it looks intuitive, actually the intuitive proof uses something what is called as Archimedean property. I'll say where it is coming. Yeah. Somebody is having a doubt. Yes?
So shouldn't we take J2 as open interval 0, 2?
Ritu, I'm not getting your question.
Shouldn't we take J2 as open interval 0, 2?
A2 as?
J2 as 0, 2.
Okay. Then what will be your J3?
For J3, we will take like minus.
Yeah. There are plenty. I'm saying it's not the same way. See, J3 you will include odd, even I can include and all. Okay. Here I want to. We are doing it in a particular way. This I want you to understand.
Okay.
Okay. Have you understood the pattern? In fact, 0 we have. See, it's symmetric, right? So we have fixed 0. I can fix any point also and work on that. Okay. We'll do this. R is union. Okay. Now can all of you say, okay, very good. 43 of you have understood the proof. Can you say what is intersection of n in n, Jn? I'm clearing all the feedback. Now go by the definition or answer. When do an element belongs to, if it is there in all the sets. Okay, X belongs to intersection of n in n, Jn if for every n in n, X is in Jn. That's the definition. So can you find out from the picture what are all the elements which are present in all the sets, right? That's going to be my intersection. See what happened to R5. None of you are responded, only except Lekashri. Kavipriya, Shweta, Darshini. Okay, R7 Ramya.
Sir, 0.
0. Intersection is a set, Ramya. Intersection is not an element. Intersection is a set. What do you mean by 0?
I thought that you were asking the intersection of that. So minus 1, open interval of -1, 1.
Ah. Suddenly from nowhere to full perfect answer. Open interval -1, 1. Why is that so? See from the picture, no? Look at this. These are all the elements, right? I am drawing in red. Okay, these are all the elements in each of the sets, right? This
Yes,
is my
sir.
J1. In fact, intersection, we are telling it to be J1, right? Okay. So it is there in J1. Look at -2, 2. These elements, all these elements are present. Look at J3, all these elements are present, right? That's what. Yes or no?
Yes, sir.
So do not say 0 or the intersection of, like again, same analogy. Okay, we are working with sets. Therefore, it should be a set. It can't be a real number. Very good. Okay, let's finish this proof. This is easier, right? So how do I prove that? How is this intersection? I like same thing. Okay, what I should say? First, I have to say intersection is contained in -1, 1. So if I pick x in Jn, okay, I have to say it is in. And then I have to say this. This is clear, right? All of you know this. -1, 1 is contained in intersection. All right? This is from the picture. If you start x here, it is in between -1 and 1. Therefore, it will be in between -2 and 2. It will be in between -3 and 3. Okay. Now look at this. Why intersection of n in n, Jn is a subset of this? I'm clearing all your feedback. Quick. I hope all of you understand this, right? See, this itself you take time. Read it in the discussion hour carefully. We have explained it through picture, but you can prove. Start with x between -1 and 1. Then -1 less than x less than 1. Therefore, it belongs to Jn, general any n, right? Because -1 is less than n, okay, less than or equal to n and greater than or equal to -n. Therefore, it belongs to Jn for each n. Okay, right. Now this question. How do we argue here? Yeah, Shalini, R9 Shalini, quick.
Let x belongs to intersection n belong to n Jn. For all n belongs to n, x belongs to Jn.
Very good. Okay. I want to claim x is inside the interval -1, 1, right?
Yes, sir.
Yeah. So how will you do that?
Choose J.
No. You have to you have to look at this carefully, right? You want to prove this, but look at if x, I want to say x is in -1, 1. How do I say? I don't have any clue. Therefore, you say, suppose x is not in -1, 1. Then what will happen? X is greater than, right? Either x is greater than 1 or x is
less.
Greater than or equal to 1 or x is less than or equal to -1. Therefore, x will not be in J1. In fact, that is J1, no? So therefore, actually, we don't require to write this. This is actually J1.
Yes, sir.
If X is not in J1, then X is not in the intersection, correct?
Yes, sir.
Because that's the definition, right? Right? Definition of intersection. If it is not in one of the sets, then it will not be their intersection. Intersection means it should be in all of the sets. Okay. I'm clearing the feedback. How many of you have understood this? Very good. Yeah. Who is the one who is having doubt? Epsiba? Yes. Yeah. We couldn't hear you, Epsiba, because of network.
So can you please repeat what you said?
I have proved intersection of n in n, Jn is a subset of -1, 1. You understand? I have proved this. How did I prove? Proof, right? If I want to prove, I have started with X naught in J1, contrapositive proof. Have you understood this? See?
Yes, sir.
Yes. Started with if X not in J1, then X not in intersection. Do you understand this first? That's what my question is. Have you understood
Yes,
this?
sir.
Because
Yes,
that's the
sir.
definition, right? If X has to be in the intersection, then X has to be in J1. What is given to me? X is not in J1, is given to me. Yes. Therefore, what is the contrapositive thing?
Yes.
Contrapositive thing is this. Can you say what is the contrapositive statement? Quick, Epsiba. If A, then B. What is the contrapositive statement? Already we have said it on the day. If not B, then not A.
Not A.
Right. Okay. So if not B means what here? If X belongs to intersection, then yeah. Can you conclude quick?
Then X belongs to J1.
That's what we want to prove, right? If X is in the intersection, then X is in J1. Do you understand?
Yes, sir. Thank you.
Okay. See, go back during discussion hour. Right? See the proof. See, here now we want to see the proof of why R is union. That also you should understand. But here we have to use a property, which is easier for us. See, when we want to prove equality, we want to prove both way containment, like whether we have. So which one is easier? Quick. Immediately, which one will follow? Quick. Good. First responded quick. Very good. Alishwari, quick.
So union is a union n to n, Jn
is
R.
a subset of R. Why? Start with the X here. Then there exists n in n such that X belongs to Jn, but Jn is given to be a subset of R. Therefore, X belongs to R. Right? That's all. Each Jn's are subset of R. Therefore, union also will be a subset of. But again, don't look like this. Go through perfect argument. Start with the X here. I'm not writing. Start with X in the union. Then what does the definition says? There exists n in n such that X belongs to Jn. But Jn is given to be a subset of R. Therefore, there exists n in, therefore X belongs to R. That's okay. We have started with X in the union and we have proved that X is in R. Right? Okay. Good. For this way around, Okay, union of n in n, Jn. Okay, we have to say this is contained in R. Okay, let's try to see the proof. Let X belong to union of n in n, Jn. Okay, then what we can say, look at the picture or direct definition. What does it say? There exists n in n such that X belongs to Jn. Okay. If you want, I can use some other notation. I'll just use n naught. Okay, so that you understand better. There is some index. So what is Jn naught? Jn naught is minus n naught comma n naught. So what is the picture? What is the picture? 0 is there, minus n naught, plus n naught. Somewhere X is there. Okay, could be anything. I don't. So now what can I say? Yeah. Oh. I'm doing again same thing, right? I have to start from the other way around. Okay, let's rub out this. Now what is that we want to prove? We want to prove R is a subset of. This we have done already. We want to prove R is a subset of union of n in n, J. Do you understand? Already I have done this proof. X belongs to union means there exists n in n such that X belongs to J n naught. But this is a subset of R, therefore X belongs to R. Okay. I thought I'm doing the other way around, but done wrongly. Okay, let's do this RSS. I'll start with X in R. Can one of you say what I have to do? I'm clearing the feedback. Quick. What is that we want to prove now? See, it should be quick, fast, be fast. I'm waiting for your response. See, I started with X in R. What is that I have to prove? Go step by step. I don't want to jump. Yeah, Srinidhi. R for Srinidhi. Quick.
So we have to prove that X belongs to union of n in n, Jn, sir.
Very good. To prove X, I'm writing all the steps so that you understand. Okay, union of n in n, Jn. For this, what I have to prove? That is to prove. Yeah, somebody else. I'll ask somebody else who have answered. They have understood. Okay, what to be proved? Lekashri, R5 Lekashri.
So there exists
to prove there exists
n in n
correct
such that X belongs to Jn.
Very good. That's what we have to prove. But what is Jn for us? See, I'm asking like each step, I'm asking questions. Okay, Jn is minus n comma n. Right? We want to prove X is in minus n comma n. Okay. Correct. Okay. Therefore, what is that? We have to really find out this to prove. Still, we have not proved. So, what is that we have to say? We have to say, okay, X is right like this in between minus n and n. Okay. So, really, what is that we have to say? We have to say, okay, let's look at, let's change this. This means actually mod X less than n. Correct? That is, in terms of modulus, it is this. That all of you have understood so far? If so, respond quickly. Very good. Right. So this is what we have to prove. That is, I'm going to write. That is to prove there is a natural number n in n such that n is greater than mod x. What is given? Okay, given a real number. Okay, I want to say that there is a natural number greater than this mod x. Okay, given a real number x to prove. Okay, this is what is called as Archimedean property. Archimedean property of real numbers. What does the Archimedean property says? The Archimedean property says Same thing. One way set of natural numbers is not bounded above. N is, this already we have seen. Okay, bounded above definition and all. N is not bounded above. By that, what do I mean? Given no number, given any real number, it will not be upper bound. So given A in R, there is a natural number N in N such that N is greater than A. I'm going, so go back to the definition of bounded above and try to understand. Okay. So this is Archimedean property. Okay. So, okay, what A we have used now? Can you capture quick? Of course, we are overshooting time, right? Quick. See, this is the Archimedean property, right? N is not bounded above. What is the meaning? I have written here. Given A in R, A is not upper bound for it. Maybe go step by step. For every A in R, A is not an upper bound of N. Upper bound of N. Okay. By that, what do I mean? There is a natural number which is greater than. These things we have done on the day. Okay. So can you say, here I have used Archimedean property, no? So what is the choice of A for me? That's my question. Yeah, R6 Rahul.
Mod of X.
Very good. I have used A equal to mod X. See, I have used X is given to me. I have started with X in R. But what all I want is there is a natural number greater than mod X. Okay. Go back. In fact, Divya, I'll take 2 more minutes. But the regular, see this is the way which we have understood the proof. See, we have understood the proof by asking questions. Started with X in A. Okay. What all I want is I have to find a natural number greater than mod X. It depends on the property of natural numbers. Therefore, we have applied natural numbers. Okay. See, while writing the proof, textbooks use the other way around. They will write standard textbook proof will be the reverse way around. They will simply say, start with the X in R. This is textbook proof. Right? What they do? They will simply say, by Archimedean property, they will apply this. There exists a natural number N in N such that N is greater than mod X. Okay. Therefore, yeah, same thing. X is in between minus N and N. Therefore, X follows in Jn. So, therefore, therefore, X is in union of N in N. It's other way around, right? So, look at this is how textbook proofs are written. Go back, please discuss this. Yeah, the discussion. But here you understand. Here we require, even though intuitively we say the proof is using argument. Right. So, Divya, I will stop here.
Thank you, sir.
Yeah. See, today, you should actively participate in the discussion now. Okay. Take part, actively participate. If you have doubt, you can always ask your mentor, discuss. Okay. See, for some of you may feel that little bit faster I have gone. Okay. Some places. That's the place where you got to capture and discuss. Right. It depends on person to person. No? Some of them would have understood, not understood. Yeah.
Yes, sir. Thank you, sir. Thank you, live stream participants. We will meet by Tuesday, 1st November. Thank you all.